So we will have this. We are also have this lecture in English. At least what we've got still. What we still got from it. So I hope the recording will be fine as well. We'll see. We talked about various different things, various different perspectives on software architecture, and if you recall, in the first lecture, but also in the last lecture, I mentioned some things regarding some more generic design that will be kind of reusable. So we've been targeting reuse on several levels, and now let's think of reuse through these two perspectives that we already talked about last time. So what the system is and what the system does. So you recall this from the last lecture that we talked about that we actually do not normally establish the architecture by going through use cases and by reinventing things that we already know about the domain. Actually not the last lecture, but the lecture before that, the lecture we talked about, at which we talked about data, context, interaction approach, and lean architecture above all. So one perspective here that we have, the left side is what the system is, and the other is what the system does, and we do not normally, as I said, go through this what the system does perspective through use cases in order to reinvent what we already know about the architecture of the systems that belong to that particular domain that we are working in. We actually try to understand the domain knowledge that we have there, and we already set some architecture in terms of objects that we are using as actually common object-oriented design, and this is actually the perspective based on what the system is actually normally valid for a single customer. It might be valid for several customers, but this is something that you want to discuss with your customer. So you talk to a customer, and then you actually establish the idea of what they want to have in their system. And normally you will use use cases or user stories or some way to confront them with your ideas in a cheap way. Yeah, so not to implement anything before they approve that they want something like that. And then along the way you'll probably have to implement some things if you're doing your things in an agile manner. So you will be exposing what you've done and then making changes. But this is not a single customer perspective. When you do the domain analysis and you analyze your whole domain, that's all customers' perspective in that domain. Also, I showed you this clean and yummy definition of what domain knowledge is. So, because we need to explore the domain knowledge. So what the domain knowledge is in their words, a timeless compression of the mental models of end users and other stakeholders. Mental models whose patterns are tacitly driven by commonality and variation. So you see here they emphasize, and this is a short, really short definition. So they actually emphasize what is important in every word. The words are carefully chosen. So there must be something in this commonality and variation. So we talked about this also regarding lean architecture. So, but we did not directly model commonality and with respect to this definition, then we can say that domain analysis intent is to capture domain knowledge by looking at the practices and systems in the domain. We are not looking only into kind of paper practices like paper office, normal traditional approach to the business before the computers were invented in the domains like banking or insurance or whatever. We are looking into how software systems are used, how these domains are being or were computerized. So we are taking into account the systems and the practices that we can encounter in these domains. So it's not really that we are just pretending that there are no software systems and we need to support that domain by implementing some software support for them. We take into account whatever there is. So in these terms, we might think, related to this, we might be wondering how to actually express domain knowledge. Of course, we are doing object-oriented design mostly. Some parts might be designed in different paradigms, different approaches. Some things actually, modern object-oriented programming languages often incorporate, and actually they've always incorporated some other features, at least some procedural things. And what other approaches do you think is, do you feel as popular besides object-oriented programming? When you program in Java, you also have such features, but in some other languages they are more apparent. In Java, now you can use lambda expressions, and lambda expressions are not a part of object-oriented programming. They are part of functional programming, sometimes called application programming. Functional programming, so there are functional approaches which are very helpful in dealing with large quantities of data, or semi-structured data or unstructured data, and when we need to invent how this data needs to be processed. So, but the overall structure that we provide is still commonly object-oriented. So we might think in objects and establish our structure in objects, but can we do better with something not directly related to the implementation mechanisms? Because we want to think, we want to have a kind of wider and deeper picture of what we need to cover. So we can speak of domain concepts, some neutral notion. We need some neutral notion in order to deal with the domain. Domain concepts. But normally, when you develop things in agile approaches, and you're currently using Scrum, how do you partition your system? What do you actually divide between yourselves to implement? How do you call those parts? You don't call them anyhow. As parts of the system? Or you say, we need our system to support some feature. So even colloquially in Slovak, you use feature. Yeah, you don't use Slovak words for this. You just say feature. Some other form of this word accommodates the Slovak language, and you actually talk about features that you need to support, and you actually divide your work into features that are necessary to be there, and who's responsible or currently implementing the most of a given feature. So let's look at let's think a little bit about eShop example that maybe I've already used in some lectures here, but it doesn't really matter because that's the domain that we know, we all know somehow naturally. So because we are using eShop systems to buy things, and maybe you developed some things for eShop system. Has anybody developed anything for some eShop system commercially? Contributed to some eShop system? Doesn't really matter. There are some generic eShop systems available that you can adapt to your needs. So maybe they will fall into very well into what we will be talking about further in this lecture. But let's think about the features of what kind of features an eShop system will support. And then there is a question that I would be asking you, which is whether we need to support product search or not, but that's maybe ahead of time. That's probably would be best if we could write down some features. So tell me some features that you normally see or would like to have in a shop system.
Add item to cart. Add item to cart.
And what cart?
Item.
Item cart. Item cart. Add an item. Add an item to a cart. Also, you can tell me that it's in Slovak if you know the name of the feature in Slovak. Don't bother. I'm going to try to translate it.
Purchase.
What does it mean, purchase?
The whole procedure from celková platba, že vlastně ten postup výběr kuriéra.
Celková platba?
Taký ten proces tej platby.
To support the whole process of purchasing goods from the e-shop or from an e-shop. Some other features? Purchase process, maybe. If I understand well, might be a bigger feature.
Filter some things, categories, or
Filter. Filter products or goods or whatever. Filter products. Maybe even sorting. But maybe this will be kind of another feature, or I don't know. I got all these features just from one guy. Any other features? We are not talking only about the features that must be there, but maybe some features that might be there. Talking about purchase process, I will I'm thinking of this feature, and I'm thinking of what kind of payment will be there. pay by cash, card, Bitcoin, I don't know whatever you want. What else can you pay with some check or what's there? By card, by PayPal. More probable than Bitcoin to be supported. Okay, so I'm already structuring somehow these, and these are also features, aren't they? But kind of sub-features to the payment, and payment is sub-feature to the purchase process. Okay, so I'm kind of already structuring it, and really I'm not sure about Bitcoin, so it might be really an optional thing, but I'm sure that I want to support cash payments and card payments. PayPal maybe either, I'm not sure about it. But for sure I will support these two. Maybe I won't support even card payment for sure. Maybe it will be kind of also an optional thing to do. So you see, we can pretty much, where are the objects here? We do not see any objects here. We see some features. Features act like actually concepts in a way, but they might be kind of sub-concepts in relation to some other concepts. So they always have the context, and the main context for all of this is eShop system. So we have all these features like this, and we can decompose them further. So we can do some kind of decomposition based on features, and maybe I don't even have to ask you this question: should an eShop provide product search? You might say yes, for sure, but imagine some very simple eShop system. So you don't have product search where there are only few products they are selling, and they actually do not need to provide any kind of product search. They only few products. They won't just, but what's necessary for them is to enable making a purchase. So I already started showing the. Why didn't you tell me that I was showing the slides? So should an eShop provide product search or not? That's what we discussed. So I've already started showing you some kind of or creating some kind of notation for this, for capturing the features. And here is a notation that can be used for this, which is called feature modeling, as expected. So because you're modeling features or modeling big features. So here you have actually one possible way of expressing your eShop, but not your one eShop system, but the domain of eShop systems. It might be not completely general, but it's general for your organization. It should be general for your organization. So in order to model the whole domain in its complete genericity and to cover all the possibilities that are there in the world and to satisfy each and every opinion on the domain, it will be an overkill. But your organization is developing eShop systems, and you need to understand what your system will support for sure, and what is optional, and how is it optional, and how is it connected to other optional things. Maybe if you select one feature, it will block selecting some other features or including some other features. So for this, this kind of notation might be very useful. to put your to provide an overview of what you offer. So here we see that this order items feature is according to the legend mandatory. So all your eShop systems will support this. All your eShop systems will support some kind. No, they will not support the custom. Dispatching items. It's like making the purchase and finishing the purchase, like dispatching to the customers. Search products is also an optional feature for us, as well as catalog. Maybe we do not need these with the most simple kind of eShop systems that we will sell. But look at this, order items actually, which covers the ordering process. So I divided this purchase process into ordering and dispatching. Ordering includes the means of payment and the possibility to select products. Selecting products is not necessarily related directly to this search products feature, but when we dig deeper into select products, we will decompose it into from the catalog directly or by search. And we will see that if we want to support selecting products from the catalog, we will understand here when thinking of this feature that it is related really to the catalog. No surprise though. Yeah. So we must know that if we are going to support from the catalog selection of products, then we must have that catalog included there. Aren't we? Or don't we? So we must have this catalog included, and then we need to record some rule that will warn us of this, so not forget that there is some kind of dependency. We could put this into this tree, but then it will cease to be a tree, and it will become a more general graph, not a fully general graph, but it will be a directed acyclic graph. Still, it's kind of fine, or maybe it won't be even the acyclic, but probably it will, I'm not sure. But anyway, we will necessarily clutter the structure of this graph. So as people we like these strictly drop-down hierarchies, and where we can get along with all the things that are displayed there. So what is proposed here with this, along with this notation, is to record these additional dependencies like this. So this is implication. So from the catalog implies catalog. Actually, this means that when you select, and these are alternative features. So as you can see, alternative features according to the legend. So you can select one of these, and from the catalog means that this feature needs to be. This is an optional feature. As you can see, this is the mark for optional feature. There might be some features that we call abstract, like eShop itself is an abstract feature, but it's not strictly speaking a part of this notation. This is kind of an additional thing that was added by this tool, and some approaches rely on this, but it's not essential. You might say that this tree alone is not enough, because other nodes might be elaborated further, and if we elaborate all the nodes further, we will have a huge feature tree. That's unbearable. Yeah, so we can actually stop decomposing it at some level, and then decompose the particular nodes like this separately, in separate trees. So search products can be decomposed like there is a basic kind and advanced kind of search products that we will implement. What does it mean, basic and advanced? I really don't know. I just made it up. So that's something, and you wouldn't know it either by just looking at the feature names. You won't know what exactly is hidden behind those features. You need some kind of feature description. So this model is not a solution, a complete solution. So you need to have an understanding. So those features are like, the feature names are like use case names. You do not model by just naming use cases. You need to provide, some people think that's possible, and they just draw use case diagrams with the bubble, all those bubbles, and not understanding and the relationship between them, but they are not capable then of explaining why is that so. And for that, you need to decompose, to express your use cases in steps. For features, you won't express them in steps, but you might provide some additional, even some additional description in natural language, or some description in some other formalisms, even using UML to show some approximate design of each feature or whatever. Or might even say that these parts of the code represent this feature, so you can map your feature to code. You might be satisfied with what's happening? Okay, so I'm adding these. Yeah, you might be satisfied with these possibilities of expressing variability. So how variable is something? So how looking at means of payment, card transfer cash. One of these can be chosen. But actually, we talked about being able to cover several of these possibilities. So we must have some kind of notation for this. And later, what has been added historically, because this approach is kind of has its roots in 90s in the method called feature-oriented design analysis. So what has been added then later are those kind of cardinalities or multiplicities, feature multiplicities. So we can see like UML-like notation that we can select one or many features out of those. The same holds for select products, one or many features, not just one. And the same for search products. It can be both basic and advanced, because we are modeling the running system that will provide these features, and we will be able to switch from basic to advanced search. If we are not, if our system will include only basic or only advanced search, then we remain with this. Okay, so only one can be selected, and one must be selected, one feature. So it is upon us, upon our organization, what are we going to support? How are systems, how do we perceive this domain of eShop? It's not the completely general picture of all possible eShops in the world. It's only for us. We've been talking about variability. The opposed to this is commonality. So we are showing common features. So some features are mandatory features, are common features, but we see that we can have even common features deeper in this structure. So you can decompose even these sub features which are actually variable. In this case, specifically, they're alternative. So you can use mandatory features even there to elaborate your features. So mandatory features are there for us not to forget about some important things that will be included in all our systems in that domain, but what we care mostly about, and what will shape our understanding of how the further development should be organized are variable features. We can use the same notation of feature modeling to express an instance of our system. So in this case, I used mostly when I selected the optional features like catalog, I decided to include it. So I made it into a mandatory feature. Also search products. And if we go deeper, so far it looks fine, but if you go deeper here to select products feature, I'm not sure whether I want to provide from the catalog directly or by search, whether I want to provide these features as something that is actually selected at source time when I made my source code, or at compile time when I compile my system, so that in runtime I cannot switch between them. I want to switch between these during runtime. Although I might at this point say that I don't want this from catalog, so I can give up this feature, so don't have it here, and have just directly and by search, but I will keep them variable. So they are not made into mandatory features, because this tree represents my running system, my eShop instance, and there I would like to enable a user to switch between these features. That's one perception of feature models. So including these so-called binding times. Binding times depend on your realization domain. This is application domain, but the binding times depend on your realization domain. So if you're using languages that are not being compiled, programming languages that are being interpreted, then you don't have compile time. Also, if you want to be really specific, you can think in terms of really detail regarding binding times. So in C++, you will be thinking including even linking time. So when the things are linked together, they're first compiled and linked. Some languages you do not distinguish. In Java, you compile it, but you do not have a separate linker, or you do not think of linking as a process separate of compiling. So it depends. That's one thing. The other thing is that if you would like to use this technique like in a really simple way, like this, without these multiplicities, and maybe with multiplicities even though, but if you'd like just to see this as a map of what is possible to have in your system, and you do not want to bother with the binding time, and you do not want to represent your particular instances, then you might think that this is what is possible to include, and not a picture of your system. What is possible to include? So there are two ways of thinking and using feature models. Sometimes they are being mixed up, and I'm not sure whether how the community is completely aware of this. These two possible uses. So let's go further to this bigger picture again. So you have any questions regarding this notation, I'm not going to make you learn the notation like this. You might be like using it a little bit in your projects to represent something, even though your projects might not be strictly related to variability, to commonality and variability. Any questions regarding this? Of course, you can ask in Slovak. No questions. So, we might even think of dynamic software product lines. That might be kind of an approach that you can encounter with some those generic eShop systems. So you have everything there, but you are switching on and off things in a configuration that is available to you at runtime. That configuration might be available only to kind of a super user, so not to all users. So normally your customer won't be able to configure whether there is a catalog or some other search support. But you as a super user, as an administrator, you may switch on and off the features of the system. And this can be also done according to some events that will make your system look differently according to the context. So, I've already included here the notion of software product lines. Software product lines. I'm not sure whether I have something. Later, I elaborate this, but as I've exposed this to you, so you might be wondering why software product lines. What is behind this? Well, think of the other notion for this is a family of systems. Family. So the systems that are related to each other, close to each other, akin like of the same kind, but look a little bit different, like brothers, sisters, and so on. So they say, kind of share some similar features of their faces, for example. So that's the metaphor behind this. Or maybe because systems are not really alive like us. Or maybe Alexander would say they should be alive, like buildings, the architecture. But anyway, we might rather think of them as products, and you have kind of a series of cars or perfumes or any other kind of products that you can imagine that are kind of belong to the same line of products. So they're a little bit different. There's a kind of, if you think about perfumes, there's a little bit different scent in some of them, but the kind of the common ground for these is the same, so it's the same quality. Or the cars, they are different in many ways and quite variable, but you have kind of a line of cars of the same manufacturer, so they can have several lines of similar cars. And the same with this. So we are talking about lines as line of similar lines of similar products. And I've already explained why dynamic. So let's go further. How to implement features. Why did we do this at all? Who knows? Mostly, actually, this notation is not. There was a research paper that some years ago, maybe the situation is different now, but I doubt it is, that actually uncovered the truth that in industry this notation is not being used. But you will be surprised how much of UML is being used in industry. There have been some studies on this as well, and not very much, not that much that we believe that it is. So it doesn't mean really that that no one uses graphical modeling or modeling as such, and that everyone is just satisfied with just, well, we just sit and program and that's fine. It's that they're using their common tools and notations. So organizations are more happy of creating their own tools, kind of adapted to their own needs and so on. And when they do so, they don't want for others to get into possession of those tools. Yeah, so they keep them for themselves, and features have been maintained in some kind of structured formats. Motorola was developing some systems like this. Nokia had an extensive family of their phones and their operating systems that they've been using the two kinds of them actually. So each one was kind of a product line in its own right. So they did not want, and the idea behind this then was like in those software product lines is also how to best commercialize things. So how not to give some things to customers if they didn't pay for them. So it's not really a very noble idea of giving away as much as you can, but then again, it makes things possible, because otherwise those companies probably wouldn't exist if they wouldn't be able to make profit. Then again, what's the use of this? If they are not doing doing exactly this kind of feature modeling, they're doing some things in future in some way. But what's the use of this? Can we use this to decide how to implement things a little bit, at least? Can we? I don't have exactly the class diagram, but if you have this, just look at these search products. Let's switch briefly. Okay, you can still look at this there and for the recording. Let's switch here, and for you to see. So search products. Still quite visible there. There's basic and advanced search products feature. So if you manage to implement the basic idea of searching for products in a kind of search manager, say so, then these things, and maybe you won't be able to provide such a search manager. It will be abstract. There's a general idea of it, but it doesn't say much about how exactly searching is done. So you can do this by deriving specific ways of searching. So here's the basic one. I would say like this, SM. short, advanced search manager. And so actually your variation in your domain is actually making you forcing you to make such decisions, and how to make such decisions is actually based on how your features are organized. Okay, so you will make decisions on the realization based on the application domain configuration. And you might decide, even plan what is crucial, what is necessary, absolutely necessary, what shall you start with. The whole process can be organized based on this. Speaking of the process, this is just what I've said in other words, repeated here, but speaking of what you can do is something like this. So this is the whole process, which is actually based on tackling the whole domain and not just individual, just requirements for the individual system. So look at the upper part of this figure. You can see there that you start with domain analysis and proceed to domain design, domain implementation. So it means that you will be implementing some generally usable applicable components, but not too generally applicable. They're applicable to you, to your company, to your context. Maybe they will exceed the borders of this and become more generally applicable, but that's not your target. Implementing a completely general or generally applicable component can be an overkill and can take too much time for you, which you will lose, and you won't get to the market. You won't be able to sell anything, and you will be kind of finished with your business before you even started. And here you can see that you go from domain knowledge, you create some kind of models for domain analysis, not necessarily just feature models. And then you go to domain design, where you design things some way, and you end up with real implementation. This does not give you any kind of, if you have a look here, any system, anything, and you are going to say monetize, to earn money from what you sell, and you need to sell a complete system. You build your system by putting together the things that you made here. So you ask, of course, your customer about their needs. You do some requirements analysis, but even here you rely heavily on what your domain model looks like. Then you actually do some design analysis, but again you heavily rely on the architecture that is based on what you already produced in your domain. And you go to integration of your components. In the best case, you will be just picking components and putting them together. The components, though, might be whole frameworks. So it's not necessary that your components are kind of just boxes that you connect and put together. So there might be whole frameworks that you put together, but this ideal case, you're not encounter it very often or at all, maybe. Almost always you have to do some custom design to adapt things, to add missing things, and such things. And then maybe your customer will require something that you did not include in your product line. So you will need to reflect these new requirements in your product line if you want to have these things readily applicable for other instances of your system. This is the kind of a general scheme of how to develop systems using this approach of software product lines. Software product lines, software product families, vector lines, we talked about this. Some people mix this notion with the notion of factory lines. You know what a factory line is? Like you have workers standing by a moving line, and they're doing their things. Each one is specialized for a particular screw or whatever. Yeah, something. They're doing their job, and things are moving according to. This is not the case here. So we're not talking about factory lines. We're talking about lines of products, of families of products. But talking about factory lines, the famous company, famous for this factory assembly line, it's called assembly line approach, was Ford. I was talking about lean approach, and I made a slight reference to Toyota company, or Toyota previously. So they actually they have a kind of a little bit different approach than to put the whole process around assembly lines. And they have a more inclusive approach regarding the management structures that are being closely watching the process and actually are being involved the moment the things go wrong. They come out from their offices and they interact with the workers and try to solve the things in the field. So it's kind of approach that we picked up for Scrum very much. So that's why Scrum kind of is neglecting the role of a project manager. We can think of this as a good approach, but we need to kind of to use, and we can be kind of attracted by the idea of covering the whole domain and being able to put each system that we need to put together for each customer just like this, just by picking features, and maybe even automatically put them together. So you have kind of a configuration tool, and you have the features, and you have the features connected to code. And there is a commercial tool called Pure Variants. Pure Variants, the reference is given under this lecture in the list of lectures. Pure Variants, which actually I'm not sure whether it is being used in this way, but some companies also might have automated the process of selecting features and putting the necessary code together for the realization of these features. But to be so general and to put everything together at once, it might be overwhelming. So we might think like this would be that case. Like you just bring this idea revolutionary, and you don't have any product base to rely upon. So you are starting developing eShop systems, you might have some experience as people. It would be good because if you would be entering this as a green field, then it would be really suicide mission. But given that you are entering this without having any kind of code base or any components, anything like that, to put together, to base your further development on, you are doing this revolutionary without product base. So development of a new product line before delivering the first product. Completely, you take 1, 2, 3 years to do this. But for those 1, 2, or 3 years, you will earn nothing. So that's very risky and problematic. The other way is to consider the existing product base. So you started your business and you developed some products. You developed and delivered successfully some of the shop systems. You changed you might have even encountered that you've been changing some things inside of your, like you had 3, 4, 5 deliveries. That you've been changing some things and you noted that some things remain stable, so that's your commonality. You identified your variability, but under time pressure, you did this not very kind of in a regular way, to say so. And maybe you even missed to document these features, so you rely on how people understand the domain that work with your organization, how did they understand what they did, so, and how the kind of transfer, or this direct transfer of the knowledge to new colleagues that enter this business without providing any extensive documentation for this. So at this point, you might decide that establishing a product line might be a good idea, and you might do this. Probably you won't stop delivering, so you feel that this is good for your business because that is your earning money and experience. So you do this evolutionary and from existing product base. So you gradually develop a product line out of the existing set of products. What does it mean to gradually develop a software product line? It means that you will be picking some parts of your software systems and trying to make them more general, rather than just adapting them from one case to another. So making them parameterized, parameterizing your variability. And in the end, you will get a kind of a product line that can stand more on its own than not. You will always need some adaptive design, of course, or adaptation design. The other two cases are that you actually don't have a product base, so you understand that there is such approach as software product lines, but you must deliver something. So you try developing your one of your products, but thinking of doing some cheap domain analysis, as I've shown you. Drawing some feature model diagrams is not that expensive, just as writing some use cases is not that expensive. So you must deliver, but you have that understanding of the existence of the approach of software product lines, and you want to apply it. And the fourth case is that you have your existing product base, and you feel that you need to kind of re-establish it differently, derive the components differently. There's some code, but you need some time. So you earn some money, you can invest in your process, so you stop delivering for a year or half a year or some time, and you devote completely to establishing a new product line out of the existing code base. But the most probable way is the gradual development of a product line out of the existing set of products. Most viable one, probably. Most of the companies actually do have some kind of this process, but if you ask them what software product lines are, they wouldn't know. Carnegie Mellon Software Engineering Institute developed this effort to promote the idea of software product lines. And it's kind of more industrially based than academically. So you can have a look. I think I have a link under the lecture. I will check that after the lecture. Software Engineering Institute. I'm sure there's a link. This link is available in that document with resources. So, what about UML? Just briefly, because I'm out of time here. UML supports classifier package parameterization. Maybe you are not fully aware of this, but let me just show you just briefly. Maybe do you know this notation? Anyone? This is a class. This is something unknown. This is role binding, so this is kind of realization. Okay, so you might understand this, that address list is a realization of this description. And this description says that we have this generic array that has these parameters. So it is parameterized by the type that will be held or carried in this array, and the number of the items that the number of the positions for the instances of that type. The default value is 10 for this, and if we specify this array like this, then we can bind our type to be this address class. So this is a class somewhere in our system, and we want to have only k going at most to 3, which means holding up to 4 items of the class type. And by this we gain a specialized address list. This is an example from the UML specification, and even Enterprise Architect enables this. Not too interesting, but can actually cover some things that you already know from languages like C++ or Java, where you can use templates or generics to implement interesting things and cover more cases. So, if you would look in the new, the latest specification, UML specification, you will find this mistake there. So this is an error that does not exist in UML. So this is an issue that was reported, but still it's there. So don't worry about this. The correct notation. No, this was not my intention. Sorry for this. So, just don't worry about this wrong notation. The other thing, more interesting thing that you might even think of using when you be kind of recovering some architecture that you are working on, might be this kind of parameterization. Here you have a whole package which is parameterized by some elements. And the elements of your package here are classes. And few of them, resource kind, and system, are special. They are not classes, they are parameters. So here you expect some class to jump in for a resource. And what class it will be, you define by this bind expression. This bind expression is somehow spoiled here, so this should be a dashed line here again. So many mistakes in the UML specification, unfortunately. So resource would be car, resource kind, car spec, specification. System will be car rental system. So you're actually defining a general way, general component or framework for resource allocation, and you're applying it in this particular case of this car rental system. So this is something that is already available in UML. But UML does not support an abstract notion of concepts, of features, and modeling features like I've shown you so far. Although you might use classes to do so. But you must imagine your classes not being classes but features. Again, if you look into the latest UML specification, you will find more elaborate example, but with wrong arrows. And there are even two. This is a double bind expression, which is interesting. That you are actually binding this resource allocation you are using to cover in this kind of training system, training administration. On one side, you are doing this to cover training or instructor allocation, and on the other side, facility allocation. So this is the same thing applicable to both, and you do both bindings, so you will get the kind of full-blown diagram. If you draw it, it will contain a kind of at least twice as much classes like this, that are actually not twice completely, but some of them, 3 of them will be doubled for each of the cases. Okay, so there's even such possibility to use the same component, same generic component twice in your system. But unfortunately, this is not what we needed what we need for feature modeling. I'm not going into this now. Maybe we'll leave it for discussion for the last 2 lecture slots that we have. This is the UML meta model, part of UML meta model. So what I wanted to show and convince you of is that regulated variability within a domain is a basis for achievable software reuse. I'm not talking about, once more, I'm not talking about covering the domain as a whole, as full kind of fully common understanding of all the people in the world, but just for your organization. There will be enough things to cover there. Okay, you consider things that you don't have for now, but you might like to have, and you find worth considering. You consider the cultural context that you are working in. So maybe e-shops in some other countries, different culture might look differently, but maybe not. Maybe banking systems are different according to culture, and insurance systems for sure might be some substantial differences. And to cover all the things, all the differences, all the possibilities is something that will overwhelm you and prevent you from delivering. So that's it for this lecture. Questions, comments, remarks? Slovak or English? Or even Russian? No comments? Okay, sorry once again for the delay and technical problems. We will continue with, actually let's have a look maybe where we are, just quick look. So here we had our 7th lecture, software product lines, and there are 2 remaining lectures like this, like just like introduction, just mostly me talking to you, aspect-oriented modularization and distributed software architecture. Here, and actually three of them. Sorry, I was thinking, I forgot about maintaining software architecture. So in these 2, distributed software architecture and maintaining software architecture, we will get back again to patterns to some extent. And this one, aspect-oriented modularization, will not be related so much to patterns. So that's kind of a thing, a different way of thinking of maybe arranging some things in software systems. So then we have two time slots free for recapitulation and discussion. So there I will expect your questions, and I can explain kind of talk more on things that I talked about, or you might have some unclarities. So whatever you wish me to talk about. So just maybe start preparing for these slots. Although there is always time to address immediate issues in each of the lectures. Okay, so that's it. So see you next time. Thank you for your attention.